Hello everyone, am I audible to you?
Yes, sir. Audible, sir.
Okay,
Good
good.
evening, sir.
Yes, good afternoon. Welcome again. So, how are things going? Before we begin, let me have a feedback on things that have been happening in the course in the last few weeks. Are you able to follow the contents? I think we have now moved to eddy resolved simulations and everything. Moved from the RANs.
Good evening, sir. Yes, sir. We are able to follow the content. No problem with that. And
Okay.
questions are also good, sir. Content is we can follow this.
Yes. You can also always ask questions on the forum. I think we have been answering each question individually. That you can also see. So, any questions to me today? I believe no questions means everything is being fine and you're all prepared for the exams then. Yeah, Subramanian, go ahead.
Not like that, sir. We are following. I mean, I can follow the content well,
Mhm.
but I have prepared some questions, but not for this question and answer session, sir. Because I am not sure. I'll go through the videos one more time, and if I'm able to get it myself, it is good. Maybe it is very small question. Shall I ask anyway? It is
Yeah, you
slightly
can ask.
output also.
You can
Okay, sir.
ask, no problem. Yeah.
Okay, sir. I am having one issue repeatedly in SST K omega model by solving in ANSYS Fluent.
Okay.
In reactive flow cases, where only when fuel is rich, solution
Mhm.
is not converging. When I go for relaxation, when I give relaxation factor, it is converging. I do not know the reason for this. I'm not sure whether it is related to something happening inside K omega.
Relaxation in the sense you're under relaxation.
Yes, sir, under relaxation, I'm giving. If I
Yeah.
give that, it is not happening for stoichiometric combustion case or lean combustion case or cold flow case.
Mhm.
Only when mixture is rich, it is
Mm.
happening. I do not know how to put the question. Maybe the
Okay.
fault lies with this that I do not know. That is all.
Okay. So that means you have this, what to say, even for the lean mixtures, you have no problem, you're saying.
No, sir, it is converging, but it is taking somewhat more time, more iterations, but that is fine.
Okay. But for rich mixtures, you're saying it is completely
Yes,
diverging.
sir. Yes, sir. It is diverging. Sometimes it is oscillating, not exactly diverging, and
Mm.
oscillating after 1,000 iterations, it is go on same pattern again and again.
Okay. So if you don't want to give relaxation, well, relaxation is a good idea to underlax is a good way to get convergence. Is it
Yes.
a unsteady problem or a steady state problem?
Unsteady, unsteady. In unsteady, what the steady is
Did you
not a
put a
problem.
dynamic time stepping or is it
Yeah,
static?
time step I usually calculate, and I calculate CFL number, and then time step also I vary depending on the case of the external
Hmm.
dimension and usual way.
Okay. So
So
in this case, did you without doing under relaxation, did you reduce the time step to see whether it will converge for the
yes,
rich?
sir, I have reduced, I have increased, all those things I have done. Fine. If, for
Increase
example, if I'm
increase will
giving
not increase will not solve the problem, but reducing the time step would have given the code to converge. Sometimes that can happen.
okay,
Anyway, the
uh,
under relaxation is always a good idea to go. I mean, if you're naturally if the solution is diverging, you want your data to be the solution, you want it to be more rely on the previous data than the current one. Under relaxation is a good idea too. Yes.
my question is why this is happening only for which? Is there something I'm missing from physics point of view? Why this is happening?
There can be many factors. It's well, first thing, it's beyond the turbulence modeling course. This is
that
something
is not,
related
I was
to.
hesitant to ask this doubt, but
Yeah. No, it's okay. You can ask questions. It's as long as it is all related to uh, something similar, it's okay.
okay, sir.
I'm not completely sure like what it would be happening. There could be many reasons in a commercial code. See, when you write your own code and then have a commercial code, there is a big difference. So you're not able to see the source code there. So it's difficult to say in a commercial software. It's a black box. Hard to say what could be going wrong there.
Okay, sir.
Hmm.
Okay, sir. Sir, then I have one small additional question.
Hmm.
Because this is also I'm having in my mind for a long time.
Hmm.
So far, I'm using only ANSYS Fluent for years. I want to learn open form. Maybe this question again feels very silly or simple. From where should I suggest any books for learning
Open
open
form.
form? Yes, sir. Open form or any other coding thing you suggest?
Yeah, actually, this course when I gave it in person on campus here to our students, this is a hands-on course. So that's why the prerequisite is CFD because they should know how to write a code because I will ask them to write codes, implement this the RANS models and all these things. But since it's NPTEL, we didn't had that opportunity. I mean, like it's possible, but then it's very difficult to evaluate for so many students because it has to be hands-on. Not everybody may be a programmer, so I need to handhold all of you to write a code is a tough task in an online course. So one way to get started, of course, OpenFOAM, you could perhaps some will learn by taking up tutorials and self-taught. Some will also go to a beginner level course. That's what I've seen. They have courses for beginner level as well as advanced courses where they will teach uh, for if you want to change something fundamentally inside the solver. But it's perfectly possible to start by yourself. It comes in a pre-compiled version. So it's
Okay.
perfectly possible to start by solving some tutorial courses and modifying.
That is how I learned ANSYS also, Fluent
Mm,
also, by
mm.
Fluid Mechanics 101 and all the videos. So OpenFOAM is the right choice, right, sir? So I'll start from OpenFOAM. Is that a good choice to start for?
I would not, there's nothing like a right or a wrong choice. You need to know what is the purpose, but like each solver may have its own strengths and weakness. So those who write custom codes have a specific problem they want to look at. For example, I do direct numerical simulation, and that I know that you cannot use OpenFOAM for that. So we have written a code in Fortran. But for some problems, let's say OpenFOAM is able to do this, then why not? You can go ahead and take a look at it. It will also give you some room for changing certain things inside OpenFOAM. So the advantage of an open source software is that you're able to see the code and potentially modify it. But if you take up a solver like OpenFOAM, which is very large, it can do multi-physics. Therefore, the code is very large. And if you want to change something very fundamental, like change the numerical scheme, implement your own numerical scheme, these things get complicated there. Small codes are easier to understand so if the purpose is only to understand how the code works, maybe you can take up a much smaller code. Like if you have to write a, let's say, a two-dimensional RANS code, that can be a few thousand lines of code. So that is much smaller to learn and modify. There are many open source codes available on if you look into CFD online website.
Oh, okay, sir.
So there are many open source codes available. You can see what they are written for. Then you can easily take it up, and if that is a motive to understand how CFD codes are written.
Yes, sir. Somehow I am not able to get what is going on behind. Now I'm
Yeah.
learning turbulence modeling, so I am looking forward to implement that, in some way, in a very minor way. That is what.
Yeah. So if you want to solve whatever you're doing right now, then OpenFOAM may be an option because it already has many such modules. You can go to from combustion to multi-phase flow to many different options are there. If you want to replicate your ANSYS problem in OpenFOAM, that is also a good idea. You can also
Okay,
do
sir.
that. Mm.
Okay, sir. Sure, sir. Thank you, sir.
Yeah. Any other questions from others? I see that many have logged in. Are there any questions in the chat box? I do not see. No. Okay. No questions?
Excuse me, sir.
Yeah, please.
Sir, do you have any suggestions that we could extend this learning from this course, like any project or something?
You mean after the course, you want to continue to work on this?
Yes.
Okay. Are you currently a student or you're working somewhere?
I'm just completed my master's.
Okay, fine. Of course, you could take up some projects and self-taught. That is not a problem. So the problems that, for example, then of course, like the choice is like you want to use an open source code, as Subramanian said. You could take up learning. I have discussed few flow problems inside the while teaching turbulence modeling, right? So you can probably take up those problems to start, like a turbulent channel flow or a turbulent quid flows, those kind of problems to start, to see what kind of solutions you would get. And you have the reference data. So you can easily start to compare and see if models are behaving as it should.
Okay, sir.
You can
Thank you, sir.
later take up complicated problems. It's better to take simple canonical problems first, where models have been designed for that. Then you can add complications.
Okay, thank you, sir.
Sir, as he asked the same question and the previous question, previous Subramanian also.
Okay.
So is there any next edition, Delta edition of this course? I mean that next what you are planning for next semester, is there any, you are going to teach any subject regarding this type of ones?
No, this is the only NPTEL course that I have
Okay.
on the turbulence modeling, yes.
So any other courses you are teaching me, because your teaching skills are very good that we can understand in a very well way.
Thank you. Yeah, of course, on campus, we teach every semester a new course.
Yes.
So coming semester, I'm teaching something called turbulence theory.
Turbulence theory.
Yeah, it will be fully theoretical because it's both experimentalist and CFD can take the theory course. But it's not going to be an NPTEL. NPTEL is only this course.
That is what you given MATLAB also in the side of that. So right now we are not using any MATLAB here.
Yes. So that is the fundamental dilemma I had. Like, so the way I teach course here is, as I said, there are projects that they will work on when they learn the theory. And these are like directly implementing, let's say, K epsilon or a K omega K omega model is what they start with. And then eventually they will implement a Reynolds stress model, things like that. So for that, the thing is, when I ask you to implement that, especially those who have not coded much or who have not done so much of the CFD as a coding exercise, you might have taken a CFD course where it's entirely theoretically taught.
Yes.
If you have never written a CFD code, even for a laminar flow,
Yes.
then it would be hard for me to expect that you would write a code for the turbulent flow, right? And that is possible on campus where we can have teaching assistants. We can use them, or we can have tutorial exercises to handhold them to get started, and people can go do group projects and so on. In an NPTEL, considering the total strength, it was difficult to get into that part.
Yes,
Maybe next time I'll think about it. This course will be given every year, so I'll think about introducing some kind of a project. I'll think about it.
Sir, can you suggest that any right now you said that CFD coding one that you said self-taught only, but
Hmm.
as a PhD scholar, so we do have some research work in this our area. So rather self-learning, it will be taught by someone. It will be a very thing that it will be. Sir, right now it is a NPTEL. That is why we are consistently coming and sitting towards this. If it is a self-taught, it will not be a much more possible way to do that things because all other works will be academic works will be there, research work will be there, it will be going on. So
Yes.
if it is possible that is next semester from your IIT Madras or some any other courses regarding to CFD coding one, let's like a beginners one.
Yeah.
So can you suggest anyone any type of course you know that
Yeah, hands-on, I don't know. I mean, it's the same there are CFD courses, but if they're following hands-on or it's going to be an exam-based, that I don't know. But when I teach the CFD course, it will be hands-on. As I said, the aim is to, since we write codes inside my lab for research purpose,
yes.
I'm training my students and along with that, all the other students.
Yes. Yes, sir. Your background is from coding this type of things, right? Like
Yeah.
developing your codes from your master's to PhD next towards here.
Yes. Yes.
Yes. So how is your experience? Can you suggest me that how to do these things?
Okay. So to get started, of course, it's there are two ways. Like either you can be start as if like let's say writing a 1D code. For example, let's say you take this channel flow, okay, and
Yes.
if you consider a special scenario like where it is coming to a steady state and it's
Yes.
fully developed,
Yes.
when that happens, whether it's laminar or turbulent doesn't matter, the entire left hand side of the equation will drop out. The unsteady term and the convective term will drop out when it is in fully developed state and also in steady state.
Yes.
And then some terms on the right hand side will also drop, eventually giving rise to some kind of a 1D solution,
Yes.
fully developed channel flow or a plane coed flow. So then writing 1D solver, and then you can compare with the reference data. You can start with a laminar flow because then you will not even have a the way turbulence interacts is that like you will have this in addition to your momentum equation, you're going to solve the k and epsilon, let's say, or k and omega, and it has a complicated source sink terms, right? So the way to start writing a solver is first, of course, looking into the governing equation.
Yes.
So if I take the, let's say, the k equation, we have to first write it in general transport equation format. So a general transport equation looks like there is an unsteady term, and then there is a convective transport term on the left hand side. And on the right hand side, you will have a diffusive transport of whatever parameter that you're solving, and then a source term. So with this, you can see that in the turbulence kinetic energy equation, left hand side is fine. You have an unsteady term, dou k by dou t, and you also have the convective term, right? So we have this uj dou k by dou xj term. That is fine. On the right hand side, there is a diffusive transport term, right? This nu plus nu t times dou k by dou xj. And anything else that is your, for example, the production rate, right? The dissipation rate. So the pk minus epsilon goes into your source term. So you will have some kind of a complicated source term sitting in your general transport equation. So if you have never written a code, it's better to start with, let's say, take up the laminar channel flow.
Yes.
Write a code, and it's like 1D, and you have an analytical solution for it. You can compare. Once you are confident about it, and it's also decoupled, right? You're solving only for if it's a fully developed steady state, 1D, then you're only solving for U momentum, not even V, right? So then there is no coupling between the U and V. So decoupled solvers are much easier to solve. Like as Subramaniam said, he's using underrelaxation. This underrelaxation is important when you're solving coupled system. Like for example, if you're solving U and V velocity together, then they're, let's say when you're solving for U momentum, in the convective part, you will have the V momentum also coming into picture, right? So you'll have this U du dx plus you will have this v du dy. So v goes into, so when solving for u, you need the v velocity.
Yes.
So that means you're solving multiple equations where they are coupled to each other. And if one equation starts to diverge, it will diverge the whole system. For that reason, Subramaniam has used an under-relaxation factor where he would say let's say the v velocity, he will use the old velocity, like 50% of the old velocity and 50% of the current one. Okay, so that he's relaxing it so that solution doesn't diverge. Those kind of a thing. So it's easy to start with a laminar flow, maybe 1D solver.
Yes.
Then you can take it into a turbulent channel flow. Again, it will become 1D when it is smooth channel flow. Only thing is you will be solving along with U bar momentum equation. You will be solving for, let's say, K and epsilon. You can even solve one equation problem, or even Prandtl's mixing length, which is even much more easier. You can try and see. So these kind of things you can build slowly.
Yes.
You can decide on which method you want to use. I recommend finite volume, but I know that some students prefer finite difference because it's more, they feel it's easier to self-learn finite
Yes.
difference. But fundamentally, I prefer finite volume because most of the fluid solvers are written in finite volume, like ANSYS Fluent, OpenFOAM, CFX, whatever you take, mostly they are written in finite volume. There is a reason for it. Finite volume, you start with a conservative form of the governing equations. That means the solutions, what you are going to get, are conserving mass, momentum, energy, or anything that you are solving at all time steps, or all intermediate steps also. For that reason, finite volume is preferred. And also you have seen in LES that we say that, like, I don't need to do an explicit filtering operation. Right? We discussed, has it been already discussed this week?
Now this week is going to be LES one.
Okay.
Eddy simulations. Large eddy simulations.
Okay. The filters is not yet discussed for you.
Yeah. So this is very, very vast. This turbulence is like, while we are going deep into that, it's like a ocean.
Yeah, of course. I mean, when the complexities increases as turbulence starts to interact with other phenomena, because many problems, Subramaniam said, he's interested in turbulent combustion.
Yes.
So then the complexities, he's not aware which equation is pulling down the system. Is it the turbulence equation diverging? Is it the combustion model diverging? Or if you're solving for a multi-phase flow, or if you're solving for some scalar transport, the complexity increases more further.
That is why, sir, getting a hands-on experience, that will be a better thing. Now, you are saying is because backside you are saying previously we don't know how it will work on. Why these limiters will be used, why modeling will be done for these things. Yes, which one will be a good thing for which one. So now we understand that everything it will be on a, right, step by step.
Yeah.
So if it will be a best thing that doing in a hands-on experience, like a simulation, starting a simulation projects, using a commercial applications only, like a starting, so that everyone will get experience on this small capsule on RNG realizable and all this one LES DNS. Then that will be using a commercial one, so not on good developing that.
Yeah. So the commercial the coding part is, if I and the team can dedicate, the coding part is the easier, because we have licenses for MATLAB that can be used for NPTEL students. But if you want to use this commercial solvers, which I agree, it's easier to start with that, because you already know which models are good and what are the strength and weakness. You can go and click and get a solution. But as part of NPTEL, we must have licenses to give out to you also. I cannot ask like you figure it out how you get that software, right?
Yes.
So the commercial licenses are very expensive for an ANSYS student.
Yes.
Right. And so for that reason, so in the part of the course, we should be able to provide every tool that is required for you. And going in commercial direction that's the problem. You understand, right?
Understood. Understood.
Yeah, so MATLAB is straightforward because we have licenses dedicated for
Yeah.
that. We can give it out, but then that requires coding projects. And so that is something I'll think about it. If it can be started as an experimental way, maybe next time.
Yeah, that will be a good thing.
Because some may be interested, some may get scared with that kind of a task, and I need to see the performance of this course, how it goes. Based on that, I can build confidence and okay, I can slowly introduce those things.
Yes, understood, sir.
But
Yeah,
if you're somewhere near the campus, you're always welcome to drop in, and it's not like the course is over and then we are strangers. So if you are in Chennai or whenever you are visiting the campus, feel
Yes,
free
sir.
to write to me and meet, and then you're welcome. All of you are welcome to visit.
Yes, sir. I will try to come to your lab because I want to see that all in a experimental way or something what you are building these things.
Sure.
So actually, I was in the SRM University AP, sir. I'm doing my project is towards electronic cooling.
Mm-hmm.
So my supervisor is working on electronic cooling. She's also from IIT Madras only. Under Sarit Kumar, sir, he completed.
Okay.
Professor Sarit Kumar. So now we are working. That is why, as a jet impingement, I am working. I am working on a jet impingement for electronic cooling. So I want to know how turbulence is working on.
Understood.
So that is what the only thing I want to know. I don't want to know code, but now I interested on to learn codes. So that is, but it's not be very. This is not time to learn in that way because there will be another backside. One more thing is there. So that is why is there some learning in a good every time. If you can able to start with starting a CFD course again in the next sem, that will be a very good thing.
Yeah, I'll definitely think about it. I mean, having it's good to also have, since I teach CFD also, it will be good to have an NPTEL course on that.
Even many of
I take it as a feedback.
Yeah, many of my colleagues also, I mean, scholars also seeing by while I'm reading the taking the course, everyone sees this professor is giving a lecture with notes, like writing like a board, writing on a board. So no one will teach like that. They'll put a PPT and they'll try to say upon like that. So
yeah,
it is very
that I don't. I mean, I don't teach like that in the campus also, because the thing is, when you put a PPT, it looks nice, but
it's not
so much information goes very fast within no time. You'll not be able to absorb. And when I write it, it's good that when you write also, there's a good thing is that you can either make an intentional, non-intentional mistakes that students will also see. If they're following, I will also know that whether they're following it, right?
Yes.
Those things happen. So this course, if you have watched if you have observed the course carefully, you would notice that there is live audience.
Yes, sir.
So
You are
taking
a class, recorded class.
So I recorded basically the class. I did not sit individually and in a room and record it. So students are there, and last semester it was recorded actually. Students were there, and I recorded it.
Yeah, that is good, sir.
That helps because they will ask questions, and then
some doubts we will get, but we will get clarity when they ask the question also.
Yes.
That is good, sir.
I'll definitely consider a CFD course in future. Yeah.
Yes, that will be a good thing that because you are already in the coding part. I seen your all your previous details from where you studied and all. So it's well and good, sir.
Yeah, I used to develop a commercial CFD software also for about 5 years. So I know what happens in the background, like certain things that we don't want users to see. When you write your own code, you will be able to see, and if you'll be able to find out the reason for a code diverging much easier compared to when you use a commercial solver.
Yes.
For example, like we would assume that users may not be knowing what to give an input. For example, they can have some wild values which is beyond the permissible range, and still you will see that the code will start to run. That's because we can reset. So we will see that if the user is giving some wrong value. Let's say the viscosity value is negative. By
Yes.
mistake, the user has put a negative value.
Yes.
We would just reset it to the default value and the code starts to run.
Yeah.
So that will not happen when you write a code. It will just crash. Right. So there are many things like this that you
Sir,
can.
why they are not integrating with AI now? Now all everything is came into AI. Everyone is right now. See, right now you see the Zoom also. I think I didn't log in from last 1 year. I think this is the second time I just log in from the last interactive section, and this even AI came into the Zoom, right? So some people no suggestions will come into picture when we do something. Right now it is upon like everything is upon data sets. So why if we give that so many of them will take that thermophysical properties are constant, they will take as everywhere, not on this, everywhere. So we all know that there will be data sets. So can be taken and will be suggested by the ANSYS itself or something. I mean, as like a commercial software or the codes itself is integrated with the AI, like it will be, then it will be also a very good thing that, as you said, negative you are the given you said that the example of negative of viscosity. So it will take that exactly what it will be. It will just show a pop-up that it is given a negative. Is it correct or not? And that negative will be corrected and exact value will be given. It will be suggestion, not like a given.
Understood. Yeah, this is something for the developers, code developers to, I mean, commercial code developers to think about it.
Yes, yes, yes. Maybe you are on that field, right? That will be
No,
like,
I mean, right now I'm not developing any commercial solver. We have a completely in-house code,
okay.
Fortran code, and those kind of a thing. So, and so the students are very sharp. So I expect them to know what they're doing. So this is not the same as, let's say, see the commercial code can be downloaded or used by somebody who has not taken a CFD course, let's say. So, but when you give a code, then that person using it must have already been trained in CFD, so they know what they're doing. So there's a difference in that aspect.
Yes, yes. Yeah, maybe there is also a chance of doing this also. So most of the some wrongs will not go and computational time will not be wasted.
Probably, yeah, I said it can be maybe something for them to think about.
Yeah. So thank you, sir. Thank you for your lectures, and hopefully I'm thinking that you will start CFD courses in next semester. That will be a very good thing. That if you are teaching any class right now, you are saying about class recorded sessions only. If you are teaching that recorded sessions, that is will be also very good thing that whatever the courses you are teaching.
Yeah, though nothing is actually recorded. I mean, this was maybe some during COVID. Of course, we were teaching all courses. I don't even recall whether we have stored all those data or because that time we had to store and share.
Yes, yes.
And it was not disorganized or edited also. It was like live Zoom calls or live classes taught and it's recorded and shared.
Yes,
So
yes, that is
I'm not sure.
maybe
Yeah.
next sem will be that this sem you are taking another courses or next sem will be taken another courses.
Yes.
Like means like a CFD course or something else like related to a turbulence or a fluid mechanics.
Yes.
So that will be a very good thing that because your teaching skills, what I seen by seeing itself, we can understand that
Sure. Thank
the
you.
expressing in the expressions in given in the notes itself also, like something somewhere it is very good. I seen somewhere it is very very large. You written it is in large way. Then I understood that it's eye catching, right, sir? It will be like it is stored inside of the mind. It will be. So that will be a good thing if you given next some courses also.
Sure, I'll
Okay,
definitely think about it's on the back of my mind to teach a CFD course also.
Yes, yes.
I'll definitely think about it.
Yes, sir. Yes, sir. Please, because it will be list will be ready before it's January, right? So that I can be able to see that which course will be taken next. I need to take we also, right?
Yes, yes. No, there's a process for that. It's not
Very
exactly
easy.
my wish that I would go and record NPTEL course.
Okay.
There's a process of
Protocol.
yeah, there's a protocol like how people will decide which course to get started and all these things. Like it depends on how many students may enroll into it and also whether such courses exist those kind of like turbulence modeling doesn't exist.
Yes, that is what, sir.
Yeah.
If you see in the NPTEL or somewhere in the YouTube also, it is not available in everywhere.
Yes. So
Yes.
CFD, there may be courses. So for that reason, we need to think. So there are a lot of uncertainties there. If the course doesn't exist, it's straightforward. If it exists, then obviously there will be a question on like how this course is.
Justification will be need to given for that. You are saying that.
Yeah, justification cannot be saying that, like tell that like, I teach very well or something like that. Then they will say, how do you know that you teach well? I cannot self-praise myself like everybody will say I teach well. So
Yeah.
then they will go with the content and the audience to see, if this is a niche course, only few will take, or is it a course taken useful for a lot of undergraduate students or students in, let's say, in under the part of AICTC curriculum, UGC curriculum, and so on. They will look into many parameters before a course is approved.
Okay.
But I'll definitely take this feedback and pitch for it.
Yes, sir. Thank you, sir. Thank you for it.
Thank you.
Hope.
Any other questions from others? I see many have logged in. Anyone else?
So,
Yeah.
could you do any workshops on this, like online workshops?
Something that I will do in future.
Okay.
I did not get the question.
Like the NPTEL is providing online workshops also, and
Okay, like
you could
short-term
do anything.
workshops. Yeah,
2-3
that is also
days
something.
workshop, like.
Yes, that is also something to think about it. That can be even hands-on, like maybe something like that. That is also yeah. I'll think about it. Right now, I have no plans on that.
Could you please share us your email ID with us? This.
This is there in my first introduction lecture. If you go to the class 1, the introduction slide itself has an email ID.
Oh, okay, sir. I
Yeah,
didn't know this.
Yeah, the first class I told how you can write email to me, or you can search my full name. You will get the email address. It's on the website, my website, or other websites. You'll find it.
Okay, thank you, sir.
Any students here who are doing, let's say, masters or undergraduate, or everybody is a PhD student? Yeah, looks like I think Subramaniam said he's already doing PhD, right? And also Manikanta.
Yes, sir. Yes, sir. I'm doing PhD.
Yes. Good. So I think Subramanian, you had a question on last time on exam.
Yes, sir. Still I'm having.
You still have it, right? Okay, exam will be MCQ type. I mean, I would suggest prepare. Take assignments seriously.
Yes, sir.
Right.
That goes without saying. Yes, sir.
Yeah. Yes. So take assignments seriously, and some questions will be. I think the split is already perhaps given to you. How?
Yes, sir. 75-25. How final
like
marks are can. Yes,
exactly.
Yes,
So
sir.
there will be some questions from NPTEL which will come as it is, and that is the norm. That is the norm protocol that we have to follow. And there will be some questions which are slightly modified. So that slightly modified from the NPTEL. There are questions to be set like that, and some will be open questions. That is where I want you to think and also answer. Not just a memory test, but also a test about how much knowledge that you have absorbed. But it will be a completely MCQ type
Okay,
question.
sir. Then fine. And the level of difficulty is similar to assignment means then completely fine, sir.
Yes.
Only thing is, every week I'm trying. Wednesday night, 12 o'clock, I'll see the marks, and I cannot get 100. And every week I'm getting 90, and I'm so. I'll get it, sir. 3 more weeks are there. This week I'll get. It's.
It's okay.
I'll work
90 is
hard in the final exam also.
90 is good. I mean, it's so when we grade at IIT Madras and also many universities follow this letter grade. I don't know what is followed at your
MIT.
university. We follow a letter grade. That means, let's say somebody gets an A, means they come in the band. Let's say, for example, 80 to 90 marks, for example, or let's say 90 to 100 is A. That's an example I'm giving. So we don't discriminate or distinguish between people who are coming in that band.
Okay.
So absolute marks is not relied upon. That is the grade we follow at IITs. We rely on a, because it's like that those can be the students falling in that or similar. They may miss out few marks here and there due to many factors, right? That may not actually reflect their true potential. And therefore, a
Yes.
letter grade is appropriate, saying that this student is falling between, let's say, anybody coming in between 80 to 100 is like A, something like that. So
The
don't
same
worry so
goes
much
here
about
also.
getting 100.
No, sir, I know it is next to impossible, but I'm giving my best because after a long time, I'm taking a course because I worked as 4 years as a research assistant professor and then doing PhD for 4 years now. So after a long time I'm studying, I'm like very childlike in studying and giving, feeling giving assignments very sincerely. I feel like a 10th standard student, to be honest. So
That is nice.
this exam is, I'm looking forward to it every week, not just your lectures. So usually you upload the course at Friday morning. For the first 4 weeks, there will always be 2 weeks of course ahead. And now after that, you are uploading only 1 week ahead, that too in Friday morning. So I'm looking forward to the time also. It's really maybe I only feel like that. It is very good, sir. Very good learning, and I'm truly grateful to you for this course. And I'll talk a little bit more after the exams. Thank you, sir.
Oh, sure. Yeah. Thank you. So
Thank you,
I
sir.
mean, this learning is a continuous process. Uh, this is like reading things. So because it's like every time we need to update. I mean, you cannot keep on teaching something which is been there all the time. So as the content evolves, we also are continuously researching, studying. So that content is what we are going to share. So learning is a continuous process, at least for researchers.
Yes, sir. Thank you, sir.
Yes. So somebody has written a comment. It's uh, says good. I'm working on an aerofoil model project for a wind turbine. Should I use ANSYS Fluent or OpenFOAM? But in ANSYS, it's very hard to validate for turbulence. Please. Why is it? This is asked by Joe. Why do you think? What? Okay, you're asking which software to use, and you're saying why is it hard to validate in ANSYS? Can you explain or elaborate this?
So, good evening, sir.
Yeah.
Sir, the thing is like I'm working on a research paper that was on a bladeless wind turbine technology. The technology is about when air passes through an aerofoil, it creates a low pressure region, and that low pressure region will try to suck the air from the outside. So I just want to replicate that research paper, and I want to do this as my final year project for my UG final year project. So I need some suggestion to work on the CFD model, sir, because for doing in 2D, it's hard to validate. So I need some suggestion. Should I use OpenFOAM? So I don't have a very good fundamentals on CFD because
Okay.
I'm UG. I'm learning, but still it's not enough for turbulence level modeling, sir.
Understood. So do you have a license for ANSYS Fluent at your university?
No, sir. I'm using student version. If I can use, I can use student academic
Okay.
version in our college.
Yeah, so OpenFOAM would require some understanding of CFD, I think, to get started with, because you see the main difference is that like there is the in OpenFOAM it is more like you have to rely on information coming in some discussion groups and so on if you are stuck with a problem, or you need somebody who is already working on that to help you out. Perhaps in the Answers Fluent, you will get a user guide and something too. I'm suggesting that because you have no CFD course background. In that aspect, perhaps it's safer to take Answers Fluent for you. But if you have already taken a CFD course, I would recommend taking OpenFOAM or something similar.
Okay, sir. Thank you, sir. How to validate it, sir? Is there any solution? Is it only trial and error, or is there
No,
any?
no. In CFD, you need to do both verification and validation. So the verification means to check whether you have done it right. For example, you don't compare it with anybody's result. You just look at, for example, you do a mesh refinement and see is your results changing. You change the time step to see if your results are changing, or you change the model to see if the results are changing. These kind of things. So you just verify if your results are varying if you change some parameters. This is called verification. You also have to do validation. That means you need to compare with some existing data. It could be an experimental data, or let's say a direct numerical simulation data. That data you need to search in the literature. Like you said, an aerofoil problem, you search in, let's say, Google Scholar or some tool like that to see if this problem has been studied, and you will find a research article or a data set. So those data sets can be used to compare your results with that one.
I've already made a proof of concept for this, sir. So for this, can I use my own data to validate it?
Then it is not called validation, because you are only self-approving. You're telling I made some data and I compare with my own data and I say it's good. That's because of uncertainties. Like let's say you're running a k-epsilon model and then getting some solution. Obviously, with model there are so many assumptions, so it's good to compare with experimental data. At least some parameters where it's available.
Okay, sir. Thank you, sir.
Yeah. Any other questions? Yeah, if there are no more questions, we can even close the session. Any last questions? Anybody? Any questions before we close? Okay. Okay, then good luck with your assignments and the course. We'll try to catch up one more time. Thank you all. Have a nice day.
Thank you, sir.
Thank you, sir.
sir.